So previously we have learned the concept of spherical mirrors. That is, there are two types of spherical mirrors, a concave mirror and a convex mirror. We have studied what these mirrors are, what type of reflection takes place from them, and we have also studied the ray diagrams for each of these mirrors. That is, a concave mirror has 6 types of ray diagrams and a convex mirror has 2 types of ray diagrams. So I hope all these concepts are clear to you guys. Now the next topic which we're going to learn in this chapter is numericals related to spherical mirrors. When we say numericals, what I mean is, let's say you're given a concave mirror of a certain focal length, let's say 10 centimeter. Now if I tell you I place this marker 15 centimeter from this concave mirror, where will the image be formed? Is this clear? So to answer this question, we have something known as the mirror formula, right? So when you apply the mirror formula, you'll get the exact value where the image is formed. Is this clear? Now before we learn the mirror formula, there's certain sign conventions we need to study. So that is what we're going to learn in this video. So let's begin, guys. So see, sign convention for spherical mirrors, there are 2 types of mirrors. So I'll divide by board and demonstrate both of them. So over here we'll discuss for a concave mirror, and here we'll discuss for a convex mirror. So the first step is, guys, let me draw the diagram for both of you so it's clear. So guys, this over here is a concave mirror. The reflecting surface is bent in, right? And this over here is the principal axis. This part over here is pole. This is F, and this is center of curvature. Center of curvature, guys, is also known as 2F. Why? It's twice the focal length. So you can also write it as 2F. Is this clear? Similarly, for a convex mirror, the reflecting surface is bulging outwards. So basically, this over here is the painted part. Let's draw the principal axis. Now, extend this over here. Is this clear? So this is the pole of the mirror. This over here is the virtual focus. This over here is center of curvature, or 2F. Is this clear? So this over here is a concave mirror, this is a convex mirror. Now the first thing is, guys, what you need to understand is the direction of incident light is taken as positive. So see, guys, light will always fall like this on the mirror. Similarly, light will always fall like this on the mirror. So whatever is towards the right, guys, is taken as positive. Whatever is towards the left is negative. So what you can do, guys, is visualize the pole of the mirror as the origin in a coordinate plane. See, guys, when we talk about a coordinate plane, this over here is the origin. Whatever's to the right, this is positive direction of x-axis. This is negative direction of x-axis. So there, guys, this over here is the origin. So whatever's to the right is positive. Whatever's to the left is negative. Similarly, top is positive y-axis. Below is negative y-axis. Anything above the principal axis is positive, and if below the principal axis is negative. So all you need to remember, guys, is your pole is the center. Anything towards the right is positive. Towards the left of pole is negative. Above the principal axis is positive. Below the principal axis is negative. That is the concept, guys. So see, guys, now there are 3 terms you need to understand. One is object distance, one is image distance, and the other is focal length. So let's go one by one. So the first thing, guys, we're going to study is known as object distance. So see, guys, object distance is denoted by the letter U. Now see, guys, this U is not the same as initial velocity, right? So in optics, U denotes object distance. Now my question to you is, on a concave mirror, where will we keep the object? So let's say we place the object over here, right? So let's say this over here, AB is my object. Now, guys, with respect to the pole, is the object on the left or right? With respect to the pole, the object is on the left, na? It will always be on the left. Left hand side means negative. So object distance is always taken as negative. So take negative. I repeat, see, my pole is basically my origin. Anything towards the left is negative. So the object will always be placed to the left of the pole, na? Hence object distance will always be taken as negative. Is this clear? Similarly, guys, we'll do it over here as well simultaneously. So we have object distance, right, which is denoted by U. Now again, guys, here object is again kept to the left, right? So here also the object over here, AB, is to the left of the pole. Left means negative. So here also we'll take it as negative. So in the numericals, guys, object distance is always taken as negative. Why? It is to the left of the pole. Is this clear, guys? Now the next thing, guys, we'll talk about is image distance. So guys, image distance is denoted by the letter V. Is this clear? Now in the case of a concave mirror, we have seen the image may be formed to the left of the mirror or it may be formed to the right of the mirror, right? That means if the image is formed to the left, it is negative. It is formed to the right, it is positive. So it could be negative or positive. So I'll write down over here, could be negative or positive, depending upon the case. So for example, the object is within the focal length, image will be positive. If it is beyond here, it will be negative. Next, let's talk about image distance in the case of a convex mirror. Now see guys, we know in the case of a convex mirror, the image formed is always to the right of the mirror. I repeat, wherever the object be placed, the image is always formed to the right of the mirror. So because the image, guys, is always formed to the right of pole. Right of pole means positive. So here image distance will always be positive. So take positive. So guys, you have to be very careful what type of mirror is given to you. If it is a convex mirror, the image distance will always be positive. Why? Because the image is always formed to the right of the pole. But in the case of a concave mirror, image could be here or here. So it could be positive or negative. And finally, the third parameter, guys, is focal length. So see guys, focal length is denoted by F. Now guys, what is the focal length? The distance between pole and focus. So my question to you is, focus is to the left of the pole. I repeat, focus is to the left of the pole. Now, anything towards left is negative. So take it as negative. So the focal length of a concave mirror is always negative. Why? It is to the left of the pole. Similarly over here guys, focal length, which is denoted by F. Now guys, where is the focus of a concave mirror? It is to the right of the pole. See, I repeat, everything guys, it with respect to pole. Anything to the left is negative, to the right is positive. So focus is to the right of the pole now, so take it as positive. So focal length of a convex mirror is positive. So this is the sign convention guys so far. I repeat, object distance in both the cases is negative. Why? Because object is always to the left of the pole. Image distance guys, in the case of a concave mirror, image could be over here or over here, hence positive or negative. In a convex mirror, image is always towards the right, hence always positive. Next, focal length guys, here it is to the left of the pole, so negative. Here focus is to the right of the pole, so positive. Is this clear guys? Similarly guys, now height of object and height of image. So see guys, the next thing we're going to learn is height of object. So height of object, that is denoted by HO. That is H and O. Now guys, see, the height of the object is always positive. Why? Object is always placed above the principal axis. So anything above the principal axis is positive now. So height of object will always be positive. So take plus. Is this clear? Same thing over here guys. Height of object, that is HO, always take it as positive. Why? See, object is always placed above the principal axis now guys. So always take it as positive. And the final parameter guys is height of image. So I'll write down over here, height of image. So see guys, when we talk about height of image, it is HI. Now guys, in the case of a concave mirror, the image can be virtual and erect, or it could be real and inverted. So whenever the image is erect, we'll take it as positive. Whenever it is inverted, negative. So it could be positive or negative. Is this clear? Similarly over here guys, height of image, which is HI. Now, in the case of a convex mirror, the image formed is always virtual and erect. Erect image means it is above the principal axis, hence always positive. So take positive. So take positive. So guys, this is the sign convention which you have to study guys. Remember guys, in every numerical, right, you have to judge depending upon what type of mirror. You have to take negative or positive. Never ever forget this guys, and it is very, very simple guys. See, the pole of the mirror is your reference. I repeat, the pole of the mirror is reference. Anything towards the left is negative. Anything towards the right is positive. Anything above is positive. Anything below is negative. So see guys, first we'll talk about the object distance. Object is always to the left of the pole, hence negative. Image could be here, hence positive or negative. Focal length, focus is to the left of the pole, hence always negative. Object height, it's always above the principal axis, positive. Image could be inverted, negative, or erect, positive. Is this clear? Similarly, convex mirror, object is always towards the left, hence negative. Now here the image is always towards the right, hence positive. Focus is towards the right of the pole, hence positive. Object height, always positive. Image is always virtual and erect, so above the principal axis, hence always positive. Is this clear? So you need to remember guys this sign convention. So I hope the convention is clear and the logic behind this is also clear. So if someone asks you guys, why is object distance taken as negative? You will say, well, pole is the reference. So because object is always towards the left of the pole, hence it is negative. So anything which is towards the left of the pole, negative, right of the pole, positive. Anything above the principal axis, positive, below the principal axis, negative. So this over here is the sign convention for spherical mirrors. So I hope the concept is clear guys. Now what I'm going to do guys is, I'm going to rub all this off and in short forms using symbols, I'm going to write down these convention over here. So I hope the logic and convention is clear.